You know what the problem is with war movies? They lie to you. Not deliberately, maybe, but they lie all the same. They show you these tremendous clashes of steel titans, Shermans facing down tigers in some French village square, commanders barking orders through the smoke, gunners sweating over their sights, that final shot that decides everything. It's dramatic, it's compelling, it makes for great cinema. It's also fundamentally misleading about how armoured warfare actually worked during the Second World War, particularly for the Germans and their vaunted panzer divisions. Here's a number that should shake everything you think you know about tank warfare. When historians and military analysts went back through the records after the war, combing through after-action reports, maintenance logs, unit diaries, and captured German documents, they found something that contradicted every Hollywood epic ever made. Tank versus tank combat accounted for less than 30% of all German armoured vehicle losses throughout the entire conflict. Let that sink in for a moment. Less than 30%. All those magnificent duels, all that tactical genius, all those gunner aces and their carefully calculated shots, they were responsible for destroying fewer than 1 in 3 panzers that Germany lost. So what happened to the rest? Where did the other 70% go? The answer is going to disappoint anyone looking for glory and excitement, because the truth is far more mundane, far more bureaucratic, and ultimately far more devastating than any shootout could ever be. The real killers of German armour were things you couldn't film dramatically. They were things that happened in workshops hundreds of miles from the front. They were decisions made in conference rooms and factory floors. They were the slow, grinding mechanical failures that no amount of crew courage could overcome. They were empty fuel tanks and missing spare parts and roads that turned into impassable bogs. Let's start with the least glamorous killer of them all, the one that military historians now recognize as probably the single greatest destroyer of German armoured capability. Logistics. That bland, boring word that makes eyes glaze over in conversation. Logistics, supply chains, maintenance schedules, spare parts inventories, fuel allocation. These weren't just background details in the German tank story. They were the story. They were the invisible executioner that killed more panzers than all the Allied tanks put together. By the time you get to 1944, the situation had become absolutely catastrophic for German armoured forces. There's this fascinating interrogation report from a captured German maintenance officer, a man who had spent years keeping tanks running, who had seen the whole system from the inside. When Allied intelligence officers sat him down and asked him about loss rates, he told them something that his own field manuals had predicted and that he had watched happen with his own eyes every single day. For every single panzer that enemy fire knocked out, for every tank that took a fatal hit from an Allied gun, 3 more were lost to mechanical breakdown and fuel starvation. 3 to 1. That wasn't exaggeration. That wasn't defeatist propaganda from a bitter prisoner. That was simple arithmetic gleaned from maintenance records and unit reports. Think about what that ratio means in practical terms. Imagine you're a panzer commander in France in summer of 1944. You roll out with 12 tanks in your company. By the end of the month, you've lost 8 vehicles. If that ratio holds, only 2 of those 8 were actually destroyed by enemy action, by American tank destroyers or British artillery or Soviet anti-tank guns. The other 6? They're sitting broken down somewhere behind the lines. Maybe one threw a track in the mud and couldn't be recovered before your unit had to retreat. Maybe another burned through its final drive and there weren't any replacements available. Maybe 2 more simply ran out of fuel and had to be abandoned. Maybe the last one developed transmission problems that would take weeks to repair, except the repair depot got bombed and there are no mechanics available anyway. Let's talk about specific mechanical nightmares because the problems weren't abstract. They were brutally, frustratingly concrete. Take the Tiger tank, that monster that has filled popular imagination for decades, the apex predator of German armour design. On paper, it was incredible. In practice, it was a maintenance disaster waiting to happen. The Tiger's final drive, the mechanism that actually transferred power from the engine to the tracks, was notoriously fragile. We're not talking about something that wore out after thousands of kilometers. We're talking about a component that needed replacement after roughly 500 meters of operation. 500 meters. That's not even a third of a mile. That's a few city blocks. Now, replacing a final drive wasn't like changing a tire. It was a complex, time-consuming operation that required specialized tools, trained mechanics, and most importantly, spare parts. And here's where the nightmare deepened. Getting those spare parts meant they had to be manufactured in Germany, survive the journey from factory to front, and arrive at your particular unit at exactly the moment you needed them. Every step of that process was under attack. The factories making Tiger components were getting hammered by 1,000 bomber raids. The rail networks moving parts to the front were being targeted by Allied aircraft. The supply depots were being blown up. The trucks carrying parts to forward units were being strafed on the roads. Meanwhile, back home in the Reich, those same factories had their own problems that had nothing to do with bombs. They were running out of raw materials. They were running out of skilled workers because every able-bodied man was being conscripted. They were running out of electricity because the power grid was being targeted. They were running out of machine tools because there was no way to import replacements. The whole industrial ecosystem was collapsing, and that collapse rippled forward to every panzer sitting in some French field with a broken final drive and no prospect of repair. The Panther tank, which many historians consider the best overall German tank design of the war, had its own Achilles heel. Beautiful machine, superb gun, excellent armour when it worked. But it required something like 200 separate ball bearings just for one vehicle. 200 precision-manufactured ball bearings. Now, Germany had concentrated its ball bearing production in a few key factories, with Schweinfurt being particularly important. When Allied strategic planners figured this out, those factories went to the top of the target list. The bombing raids on Schweinfurt were brutal, sustained, and effective. Production dropped dramatically. And when ball-bearing production drops, Panther production drops. When Panther production drops, frontline units don't get replacements. When units don't get replacements, they get weaker. When they get weaker, they lose battles. There's this heartbreaking letter that survives from a German mechanic writing home to his family. He's not at the front. He's at a rear area workshop, supposedly safe, supposedly away from the fighting. But his frustration bleeds through every line. He writes about having these magnificent machines, these Panthers and Tigers that can destroy anything the enemy puts in front of them, sitting useless in the repair yard. Not because they took battle damage, not because enemy fire knocked them out, but because they're waiting for some tiny gasket, some seal worth pennies, some small component that nobody can provide. He's surrounded by the most advanced armoured vehicles in the world, and they might as well be statues because without that one little part, they're just very expensive metal sculptures. This was the reality of German armoured warfare that nobody talks about. The Panzers weren't just fighting Shermans and T-34s and Cromwells. They were fighting an enemy far more relentless, far more patient, and far more certain of victory. They were fighting attrition that began the moment raw steel left the smelter and didn't end until the burned-out hulk was abandoned in some ditch. Every step from factory floor to battlefield was under assault, and each broken link in that chain meant another tank that couldn't fight, no matter how brave its crew or how brilliant its commander. But mechanical failure and supply problems, as devastating as they were, had company in the tank-killing business. The second greatest destroyer of German armour was even simpler, even cheaper, and even more effective. Mines. Landmines. Those crude, simple devices that you could stamp out by the millions in any halfway decent factory. The Soviets alone planted an estimated 200 million of them across the Eastern Front. 200 million. Try to visualize that number. If you laid them end to end, they'd circle the Earth multiple times, and each one was cheap to make, maybe a few dollars worth of explosives and metal, easy to deploy, impossible to detect with the technology available at the time. Now here's the economics of the situation. A Soviet TM-41 anti-tank mine cost roughly $3 to manufacture. A King Tiger, the heaviest and most expensive German tank to see combat, cost about 300,000 Reichsmarks, which translated to something like $100,000 at the wartime exchange rate. So you're looking at a $3 device that could mission kill a $100,000 vehicle. That's not warfare. That's a business disaster. That's an investment strategy designed to bankrupt your opponent. And here's the thing about mines that made them particularly effective against German armour. They didn't have to destroy a tank completely to take it out of action. They just had to snap a track, just had to damage the suspension. That's it. Once you've immobilized a 60-ton vehicle in the middle of the Russian Rasputitsa, that twice-yearly mud season when the roads turn into bottomless bogs, you've effectively killed it. A Panther with a severed track sitting in 3 feet of mud isn't a weapon. It's an obstacle. It's a target. It's a problem for the engineers to somehow recover before the Soviets show up, and good luck with that when your recovery vehicles are also stuck in the mud and you're under artillery fire and the front is collapsing. The American experience in Normandy and the subsequent campaigns in Western Europe told exactly the same story. When US Army analysts went back through the records after the war, compiling statistics on how German tanks were actually destroyed, they found that mines and improvised explosive devices accounted for more kills than bazooka teams and tank destroyers combined. More than bazookas and tank guns. Combined. All those infantry anti-tank weapons, all those carefully positioned ambushes, all those brave soldiers sneaking close enough to take a shot, they were less effective than things planted in the ground days or weeks before, waiting silently and patiently for something heavy to roll over them. There's a quote from a German armoured commander that captures the psychological impact perfectly. He said something like, "We scan the horizon for enemy tanks, we watch for anti-tank guns, we train our gunners and maintain our vehicles, and all the while the real danger is waiting beneath our tracks, invisible and unavoidable." The battlefield looked deadly, with its artillery and machine guns and aircraft and enemy armour, but the ground itself was deadlier. The earth had been transformed into a weapon, and there was no tactical brilliance that could completely defend against it. You could post scouts. You could use mine detectors when you had them. You could watch for disturbed earth. But eventually, probability caught up with you. Eventually, somebody drove over something, and another tank was gone. So we've covered mechanical failure, the silent killer that claimed 3 tanks for everyone lost to enemy fire. We've covered mines, the cheap equalizer that could destroy the most expensive vehicles for pocket change. Now let's talk about what actually did the most damage in direct combat. And it's not what most people guess. It wasn't tank versus tank duels. It wasn't anti-tank guns, though those were certainly deadly. The biggest killer of German armour in actual combat was artillery. Artillery. Good old-fashioned indirect fire. Shells lobbed from kilometres away by guns you couldn't see, fired by crews who often never laid eyes on their target, directed by forward observers or aerial spotters or radio intercepts. The Soviets turned this into an art form with their concept of the pack front, which translates roughly as anti-tank front, but really meant massing artillery in absolutely staggering numbers. We're not talking about a battery here and there. We're talking about hundreds of guns concentrated on a relatively small sector of the front. When Soviet commanders identified a German armoured thrust, they would bring down a deluge of high-explosive shells that didn't just stop the advance. It erased entire map grid squares. The fire was so intense, so concentrated, so sustained that it became impossible for tanks to operate in the target zone. Here's what made artillery so particularly devastating against armour. The guns didn't need direct hits to kill. A heavy shell, like a Soviet 152mm howitzer round, landing within 10 metres of a tank could flip it over like a child's toy. The overpressure alone could stun or kill crew members inside. The concussion could damage instruments, jam turrets, break periscopes. A near miss wasn't a lucky escape. It was cumulative damage that degraded the vehicle's combat effectiveness with each successive shell landing nearby. Take enough near misses and systems started failing. The radio stops working. The gun sight gets knocked out of alignment. The engine starts running rough because something got jarred loose. The crew gets progressively more shell-shocked and unable to function effectively. The Battle of Kursk in summer of 1943 provides a perfect case study. This was supposed to be the great German armoured comeback on the Eastern Front, the last major German offensive operation in the East. The Wehrmacht concentrated something like 3,000 tanks and assault guns for this operation, an enormous armoured fist intended to smash through Soviet defences and restore mobile warfare. The Soviets, who had excellent intelligence about the coming offensive, prepared accordingly. They prepared with mines, yes, but more importantly, they prepared with artillery. Massed artillery on a scale that's hard to comprehend. When the German tanks rolled forward into the Soviet defensive positions, they encountered artillery fire of an intensity that veterans described as apocalyptic. The Soviets had pre-registered their guns on likely approach routes. They had ammunition stockpiled in quantities that seemed unlimited. They had forward observers calling down fire at every German concentration, and the effect was devastating. Soviet artillery batteries destroyed more German tanks in the first 3 hours of major engagements than tank versus tank combat managed in 3 full days. Think about that ratio, hours versus days. And we're not talking about a few vehicles here and there. We're talking about entire formations being shattered before they could even close with the enemy's armoured forces. On the Western Front, American artillery proved even more terrifying thanks to a technological innovation that German tank crews learned to fear above almost anything else. The proximity fuse, also called the VT fuse, which stood for variable time. This was a miniaturized radar system built into an artillery shell that would detonate the round in mid-air, typically about 20 or 30 feet above the ground. Instead of having to score a direct hit or rely on the shell landing close enough for ground burst fragmentation, American gunners could now create airbursts directly over enemy positions. For tank crews, this was a nightmare scenario. German armour was designed with the assumption that threats came from the side and front, where the armour was thickest. The Tiger had frontal armour up to 100 millimeters thick in places. Even the thinner side armour was substantial. But the top armour, the roof of the hull and turret, was often only 25 millimeters thick or less. It had to be thin. If you made the top armour as thick as the front armour, the tank would be impossibly heavy. So the top was the Achilles heel, the weak point that designers accepted as a calculated risk because aerial threats were supposedly manageable. VT-fused artillery shells changed that calculation entirely. When a shell burst above a tank, it sent shrapnel screaming downward through the thinnest armour. Tank commanders who were riding with their heads out of the turret for better visibility, which was standard practice because buttoned-up visibility was terrible, were particularly vulnerable. There are accounts of crews being found with their commander decapitated in his position, killed by shrapnel before he even realised the barrage was incoming. Other crew members could be wounded or killed through open hatches or vision ports. Even when the crew survived, the tank itself could be damaged in ways that weren't immediately obvious. Periscopes shattered. Antenna severed. External stowage bins shredded, losing critical supplies and equipment. One Panzer veteran, speaking after the war, admitted that American artillery was the thing that frightened him most, more than enemy tanks, more than aircraft, more than anything else on the battlefield. Because, as he put it, you couldn't duel with artillery. You couldn't see it to shoot back. You couldn't outmaneuver it because it could drop shells anywhere on the battlefield. You couldn't armour against it effectively because there was always a weak point for the shrapnel to exploit. All you could do was hope you weren't in the target zone when the shells started falling, and if you were, you prayed that probability worked in your favour, and none of the hundreds of pieces of shrapnel found their way through some gap in your armour. But the most inventive way to kill a tank, the method that really showcases the adaptability and cleverness of infantry when faced with armoured opponents, might be the humblest of all. The Soviet PTRD-41 anti-tank rifle. Now, calling this thing an anti-tank rifle is almost misleading by the later stages of the war. When it was designed in the late 1930s, it could actually penetrate the thin armour of early tanks. By 1943 or 44, when you're facing Panthers and Tigers, The 14.5mm bullet bounced off the armor like a pebble, completely ineffective as a penetrator. Which is why the Soviets stopped trying to penetrate and got creative instead. Soviet infantry discovered that while you couldn't punch through the armor with a PTRD, you could wreck everything on the outside of the tank. Vision blocks, periscopes, antenna, gun sights, external fuel tanks, track links if you hit them at the right angle. And most importantly, you could terrify the crew into making mistakes. A German tank crew taking 20 or 30 heavy rifle rounds hammering against their hull would naturally button up, sealing every hatch to avoid the chance of a lucky shot finding its way inside. But once you're completely buttoned up, your visibility goes from poor to nearly non-existent. You're looking at the world through a few narrow periscopes and vision blocks, and if those get damaged, you're basically blind. A blind tank is a dead tank, even if it hasn't been destroyed yet. Blind tank drivers would drive into ditches, into buildings, into obstacles they couldn't see. Blind tank commanders couldn't coordinate with other vehicles or respond to infantry threats or identify targets effectively. The tank became a deaf, sightless box rolling around the battlefield, useless in the kind of fluid combined arms combat that characterized the later war. And the beautiful thing, from the Soviet perspective, was that PTRD rifles were cheap and simple to manufacture. The Soviet Union produced approximately 471,000 of them over the course of the war. Each rifle cost about 193 rubles to make, which was a pittance compared to any armoured fighting vehicle. So once again you have this perfect example of asymmetric warfare rendered in cold arithmetic. A rifle costing less than 200 rubles could mission kill a Tiger tank worth 300,000 Reichsmarks by simply blinding it. You didn't need to destroy the tank. You didn't need to kill the crew. You just needed to make them ineffective, and concentrated anti-tank rifle fire could absolutely accomplish that goal. It's the kind of tactical innovation that doesn't make it into Hollywood movies because it's not dramatic enough. There's no fiery explosion. There's no heroic kill shot. Just patient riflemen systematically destroying vision equipment until the tank crew gives up or makes a fatal mistake. And then we come to aircraft, specifically fighter bombers carrying rockets or bombs, which added yet another dimension to the threat matrix facing German armour. The Allies, particularly the British and Americans, developed what they called the cab rank system, which is one of those perfectly British names that makes a deadly concept sound mundane. The idea was simple. You kept rocket-armed aircraft circling over the battlefield like taxis at a cab stand. When ground forces spotted enemy armour and radioed the coordinates, fighter bombers would peel off and attack within minutes. The response time was incredibly fast, and the psychological impact was enormous. Now, here's an interesting statistical reality about these attacks. Hawker Typhoons firing rockets, which were the primary British tank-hunting aircraft, were actually quite inaccurate. Studies done after the war found that direct hit rates hovered somewhere below 5%. 95% of the rockets missed their intended target. From a pure efficiency standpoint, that sounds terrible. But here's what the statistics don't capture. The fighter bombers didn't have to hit to change the entire tactical situation on the ground. The psychological shock of being rocketed from the air was absolutely paralyzing for panzer units. You'd hear the aircraft diving, hear the whoosh of rockets launching, see the explosions walking across the landscape toward you. Even if none of the rockets hit your tank, even if all of them missed by dozens of meters, the experience was terrifying enough to change behavior. German armored units started refusing to move during daylight hours when aircraft might be present. They bunched up under tree cover, trying to hide from aerial observation. They only dared to move at night, creeping along roads without headlights, trying to avoid detection. This behavioral change is what really killed them, not the rockets themselves. Once you've got German armour frozen under trees, bunched together, immobilized by fear of air attack, they become perfect targets for everyone else. Artillery observers can pinpoint their locations and call down fire on stationary targets. Infantry can probe and find them. Other tanks can maneuver to advantageous positions while the Germans stay paralyzed under cover. The aircraft didn't need to destroy tanks with direct hits to be enormously effective. They just needed to create enough pressure, enough fear, enough disruption to strip away German tactical flexibility. And once an armoured formation loses its mobility, its ability to manoeuvre and concentrate at decisive points, it's already halfway defeated. Let's zoom out and look at the bigger picture, the strategic reality that made all these tactical problems insurmountable. Germany manufactured roughly 49,000 armoured fighting vehicles of all types during the entire war. Tanks, tank destroyers, assault guns, all of it together, about 49,000 vehicles. Now, that's not a small number. That's actually quite impressive for a nation that started the war with a relatively modest industrial base compared to its enemies. But here's the problem. Arrayed against Germany were enemies who collectively produced something like 227,000 armoured fighting vehicles. Think about those numbers for a moment. Germany was outnumbered more than 4-1 in production alone. And remember, tanks weren't killing tanks anywhere close to a 1-to-1 exchange rate. Even if German armour had been dramatically superior in combat, which is debatable, the sheer weight of numbers made defeat inevitable. You can't sustain a 4-to-1 production deficit when you're also bleeding vehicles to mechanical failure, mines, artillery, air attack, and all the other non-combat losses we've been discussing. The attrition wasn't just happening on the battlefield. It was happening before tanks even reached the front lines. Bombers were hitting the factories making the components. Bombers were hitting the assembly plants putting tanks together. Bombers were hitting the rail yards and bridges and tunnels that would move finished vehicles eastward or westward to the fighting. Bombers were hitting the synthetic fuel plants that produced the gasoline and diesel needed to run the vehicles. Every step of the process was under attack, and each successful attack rippled forward to frontline units in the form of fewer tanks, fewer spare parts, less fuel, and lower combat effectiveness. And then there's the fuel situation specifically, which deserves its own discussion because it became absolutely critical by the later stages of the war. Germany never had secure access to major oil fields. They had the Romanian fields at Ploiești, which were vital but limited in capacity and increasingly targeted by Allied bombers. They had synthetic fuel production, which was technologically impressive but incredibly vulnerable to air attack and required enormous amounts of coal and other resources. By late 1944 and into 1945, fuel was rationed so strictly that tank units sometimes couldn't conduct training exercises. New crews arrived at the front with minimal driving experience because there wasn't fuel available to practice. Imagine being a Panther driver arriving at your unit in early 1945. You've had maybe 20 hours of actual driving time during your training because fuel was so scarce. Now you're expected to operate this complex, temperamental vehicle in combat conditions, possibly at night, possibly under fire, possibly on terrible roads. The Panthers required skilled, experienced drivers to handle properly. The transmission was tricky. The steering was heavy. The whole vehicle demanded a delicate touch and an understanding of its quirks. Inexperienced drivers made mistakes. They stripped gears. They broke transmissions. They threw tracks. They got stuck. Each driver error added to the maintenance burden and the loss rate, creating a vicious cycle where fuel shortages led to poor training, which led to more mechanical failures, which required more spare parts that weren't available. And speaking of training, the quality of German tank crews declined dramatically as the war progressed. The experienced crews from the early war years, the men who had fought in Poland and France and the early campaigns in Russia, they were increasingly killed, wounded, or captured. Replacing them were younger men with less training, less experience, and less time to develop the kind of instinctive teamwork that made tank crews effective. A good tank crew functioned like a single organism, with each man knowing his job so thoroughly that he could perform it under the worst conditions imaginable. Building that kind of cohesion took time and practice, both of which were in increasingly short supply. Meanwhile, Allied tank crews were getting better. American tankers in particular improved dramatically from the early days in North Africa to the final campaigns in Germany. They had time to train, they had fuel to practice, They had enough replacement crews that losses could be absorbed and the average experience level could increase. They had radios in every tank, which made coordination dramatically better. They had good logistics that kept vehicles running. They had air superiority that let them move without constant fear of attack from above. All the things that Germany was losing, the Allies were gaining. But perhaps the darkest ledger entry in the whole story of German armoured losses, the saddest and most telling statistic, comes from the very end of the war. By 1945, particularly in the final weeks and months, more German tanks were destroyed by their own crews than by enemy weapons. Let that sink in. More tanks were deliberately blown up by the soldiers operating them than were knocked out in combat. When you're out of fuel, out of ammunition, out of replacement parts, out of hope, and the enemy is closing in, the standard procedure was to wire demolition charges to your tank and destroy it rather than let it be captured. Wehrmacht maintenance reports from April 1945 read like a litany of despair. Destroyed by crew, abandoned, lack of fuel, self-demolition, deliberately destroyed. Over and over, the same phrases repeating. These weren't tanks destroyed in glorious battle. These were perfectly functional vehicles, or at least repairable ones, being blown up by their own crews because the entire system that kept them running had collapsed. The enemy didn't need to be there in person to claim these kills. The collapse of infrastructure, supply networks, industrial capacity, and hope did the job more thoroughly than any Allied tank unit could have managed. This is the part that really drives home the fundamental reality of mechanized warfare in the industrial age. Wars aren't won by individual weapon systems, no matter how superior. Wars are won by the systems behind those weapons, the factories that make them, the supply networks that sustain them, the training establishments that crew them, the fuel refineries that power them, the political systems that organize all of this into coherent national effort. Germany designed magnificent machines that could dominate any single engagement, and the historical record backs this up. A well-crewed Tiger or Panther in a good defensive position was a formidable opponent that could destroy multiple enemy vehicles before being knocked out. But modern war is not a series of isolated duels. It's not a jousting tournament where individual champions face off. It's a grinding test of entire national economies, entire industrial systems, entire social organizations. It's a production line that runs day and night. It's a rail schedule that has to get parts from factory to front without interruption. It's a repair depot that needs to be stocked with every component that might fail. It's an air force that can keep enemy bombers away from your factories. It's a navy that can protect your merchant shipping. It's a political system that can mobilize resources without collapsing into infighting. Germany lost in all these dimensions, and no amount of tactical brilliance at the sharp end could overcome those systemic failures. The Allies, and particularly the Americans and Soviets, turned all these systemic advantages into what might be the most efficient tank-killing system ever devised up to that point in history. Not through individual weapon superiority, though they certainly had good weapons, but through the combination of mass production, reliable logistics, overwhelming firepower, and the ability to absorb losses and keep fighting. An American Sherman tank might be inferior to a German Panther in a head-to-head duel, though that's more debatable than popular culture suggests. But for every Panther Germany built, America could build 5 or 6 Shermans. And those Shermans came with fuel, they came with spare parts, they came with ammunition, they came with trained crews, they came with air cover overhead and artillery support and engineer support and all the other things that made them part of an effective combined arms team rather than isolated weapons fighting alone. The Soviet T-34 was arguably a better tank than the Sherman in many respects, and the Soviets could produce them in absolutely staggering numbers. Soviet tank production ramped up to levels that seemed impossible. Factories east of the Urals, safely beyond German bomber range, churned out vehicles with brutal efficiency. Quality control was sometimes questionable. Finish was often rough. But the vehicles were functional, they were available, and there were thousands and thousands of them. When you can accept higher losses because you know replacements are already on the way, when you can use your armor aggressively because losing 20 tanks today is acceptable if it means destroying 10 German tanks and advancing the front line, your whole tactical calculus changes. This is why the Eastern Front became such a graveyard for German armor. It wasn't just that the Soviets had more tanks, though they certainly did. It was that Soviet commanders could afford to trade losses in ways that German commanders could not. A Soviet tank army that lost half its strength in an offensive could be rebuilt in weeks. A German panzer division that lost half its tanks might never recover to full strength again. The mathematics of attrition favoured the side with deeper reserves, better production, and more reliable logistics. And every single advantage the Allies had was amplified by their air superiority. Once the Luftwaffe lost control of the skies, German ground forces were operating under constant observation and intermittent attack. Supply convoys couldn't move safely during daylight. Rail traffic was constantly disrupted. Troops couldn't concentrate without being spotted and targeted. Tank recovery operations became incredibly risky because the recovery vehicles themselves were vulnerable to air attack. The whole tempo of operations slowed down because everything had to be done under cover of darkness or bad weather. Think about how this affected tank recovery specifically, which is crucial for understanding loss rates. When a tank broke down or took repairable damage in combat, you needed to recover it quickly before the tactical situation changed. Ideally, you'd have specialized recovery vehicles, heavy half-tracks, or tank-based recovery vehicles with winches and cranes that could pull disabled tanks out of ditches or tow them back to repair facilities. But recovery operations take time. You've got to secure the area. You've got to get the recovery vehicle into position. You've got to attach the tow cables properly. You've got to slowly extract the disabled tank and then tow it, often at walking pace, several kilometers back to safety. All of that is difficult enough under the best circumstances. Now try doing it while enemy aircraft are circling overhead looking for targets. Try doing it when artillery observers can call fire down on any concentration of vehicles they spot. Try doing it when enemy ground forces might counterattack at any moment. The risk becomes enormous. The recovery teams themselves become vulnerable. And if the tactical situation deteriorates, if friendly forces have to retreat, you might have to abandon the disabled vehicle rather than risk more troops and equipment trying to save it. So a tank that might have been repairable under better circumstances becomes a permanent loss because the operational environment made recovery impossible. The Germans faced this problem constantly in the later war years. The Soviets, pushing west with enormous momentum, often overran German positions before disabled tanks could be recovered. In the west, after Normandy, the Allied advance created similar problems. A Panther that threw a track during a retreat that should have been a temporary loss, maybe a day or two in the workshop. But if the front line is collapsing and you don't have time to recover it before American units arrive, you destroy it and move on. Loss of air superiority and loss of tactical initiative combined to turn repairable damage into total losses, adding yet another multiplier to the attrition rate. Let's talk about some specific campaigns to make this concrete. Operation Bagration in summer 1944, the Soviet offensive that destroyed German Army Group Center, provides a perfect case study in how all these factors combined to devastate German armor. The Soviets achieved massive numerical superiority, something like 4 or 5 to 1 in tanks. They achieved surprise through excellent operational security and deception. They opened with artillery bombardments of unprecedented intensity. They exploited gaps with deep penetrations that cut off German units and severed supply lines. For German panzer units caught in the encirclements, the situation became hopeless. Supply lines were cut, so fuel and ammunition stopped arriving. Repair facilities were overrun, so damaged vehicles couldn't be fixed. The order came to break out and retreat, but you can't retreat without fuel. Tanks were abandoned by the hundreds, sometimes thousands. Crews either tried to walk out, which was usually fatal, or they surrendered. The Soviets captured intact or repairable German tanks in such numbers that they could have equipped entire units with them. Most were simply scrapped because Soviet logistics couldn't support maintaining German vehicles, and why would they want to when they had plenty of their own tanks? The destroyed vehicles from Bagration show up in the statistics as combat losses, and technically they were. They were lost during combat operations, but most of them never fired a shot in their final hours. They were abandoned due to fuel starvation, or destroyed by crews who had no way to move them, or simply left behind during the chaotic retreat. Enemy action created the conditions for the losses, but the immediate cause was systemic failure. No fuel, no ammunition, no parts, no hope. Or look at the Normandy campaign from the German perspective. Panzer Lehr Division arrived in Normandy as one of the most powerful armoured formations in the Wehrmacht, fully equipped, well-trained, ready for action. Within weeks, it was effectively destroyed. Allied fighter-bombers hammered it during movement. Allied artillery shattered it when it tried to concentrate. The few times it achieved tactical success in combat, it couldn't exploit because fuel supplies were inadequate and replacements for losses weren't available. By the time of the Falaise Pocket in August, the survivors were fighting with a fraction of their original strength, and most of what remained was destroyed or captured in the encirclement. Again, combat losses in the technical sense. But if you read the unit records, you see the same patterns. Vehicles abandoned for lack of fuel. Vehicles destroyed by crews during retreat. Vehicles damaged by air attack and left behind because recovery was impossible. The actual tank versus tank engagements accounted for relatively few of the total losses. The division was ground down by the entire weight of Allied material superiority, expressed through air power, artillery, logistics, and the simple to sustain losses and keep fighting while the Germans could not. By the time you get to the final campaigns in Germany itself in early 1945, the situation had become surreal. German industry was still producing tanks, even in the face of constant bombing and material shortages. New vehicles were rolling off assembly lines in March and April of 1945. But there was nowhere to send them. The rail network was so thoroughly destroyed that moving tanks from factories to combat units was nearly impossible. When tanks did reach the front, there often wasn't fuel to operate them or trained crews to man them. Brand new Panthers were discovered by Allied troops, still in their factory paint, abandoned in rail yards because there was no way to move them further. There are photographs from the final weeks of the war showing rows of German tanks sitting intact, unscratched by enemy fire, simply abandoned. Sometimes they'd been driven a few dozen meters from where they were unloaded before running out of fuel. Sometimes crews had never even attempted to operate them because there was no point. The infrastructure needed to support armoured warfare had collapsed so completely that the vehicles themselves became irrelevant. Having a Tiger tank with no fuel, no ammunition, and no way to get either is the same as not having a tank at all. Actually, it's worse than not having a tank, because now you've tied up industrial resources and transport capacity to produce and move something useless. This gets at the fundamental lesson that emerges from studying German tank losses. Weapon system quality matters, but it's only one variable in a vastly more complex equation. You can have the best designed, most powerful tank in the world, and it becomes worthless if you can't produce enough of them, or if you can't keep them supplied, or if you can't train crews to operate them, or if you can't protect your supply lines, or if you can't prevent enemy air forces from hunting them, or if you can't recover them when they break down. All these factors interact and multiply each other. Weakness in one area creates vulnerabilities in others. Strengths in one dimension can be negated by failures elsewhere. Germany had brilliant engineers who designed remarkable vehicles. They had brave crews who fought with tremendous skill. They had experienced commanders who understood armoured tactics as well as anyone. None of it was enough because the system supporting those weapons, crews and commanders was collapsing under the combined weight of strategic bombing, naval blockade, multi-front warfare and economic exhaustion. The factories couldn't produce enough. The logistics network couldn't deliver what was produced. The training establishment couldn't crew what was delivered. The fuel industry couldn't power what was crewed. And the tactical situation didn't allow for the kind of methodical, careful operations that might have conserved resources. So when we ask what really killed German tanks, the answer isn't a single weapon or a single cause. It's the interaction of dozens of factors that created an environment where tanks were consumed faster than they could be replaced, where losses to mechanical failure exceeded combat losses, where the whole system of industrial-age warfare turned against Germany and ground its armoured forces into scrap metal and statistics. The tanks didn't fail. The system failed, and no amount of tactical genius or technical superiority at the vehicle level could overcome that systemic failure. The greatest slayer of German armour wasn't an enemy tank ace waiting in ambush with a perfect shot lined up. It wasn't some wonder weapon that Allied engineers developed specifically to counter German tanks. It was the patient, relentless, unglamorous work of logistics, industry, and strategic pressure applied across every dimension of warfare simultaneously. It was the arithmetic of attrition playing out exactly as it had to given the balance of resources and industrial capacity. It was the slow strangulation of supply networks and production capacity until even the best weapons became paperweights. This is the story that doesn't make it into popular culture because it's not dramatic enough. There's no climactic duel, there's no single decisive moment, there's just the slow, grinding reality of industrial warfare consuming resources and men and equipment until one side can no longer sustain the effort. That's what killed the Panzers. Not enemy fire primarily, though that played its part, but the whole infrastructure of modern war turning against them, creating an environment where every sortie consumed irreplaceable resources, where every battle was won at a cost that couldn't be sustained, where the mathematics of production and logistics made defeat inevitable regardless of tactical outcomes. That's the lesson. That's the truth that Hollywood won't show you. That's what really happened to German armour in World War II.